Welcome back, students. This video, we're going to cover Lesson 8-3, SSS and SAS Similarity, also known as side, 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 and side, angle, side similarity. So, look to the left. So, start with side, side, side. So, if all the corresponding side lengths of two triangles are proportional, should have grabbed this to begin with, then the triangles are similar. All right, so what it means, they have to be in the same proportion like a fraction, like we were doing before. So we use this to prove the sides. Last lesson we were just talking about angles, and we did the sides and everything, but we were kind of focusing on that. This time we're going to focus more on sides. So we got these two triangles. Let's say JK to MP. You'll notice left to right, top, bottom. All right, KL, PQ, LJ, QM. And if that's the case, then triangle JKL is similar to triangle MPQ. All right, for side angle side, if two sides of one triangle are proportional to two sides of another triangle, and the angle in between, or the included angle, as you've heard it mentioned before, is congruent, then the triangles are similar. So for this guy, they've shown that angle S and angle Y are congruent right here. So we got RS over XY, so RS XY, and then ST YZ, so the two sides and the included angle. All right, let's look down here to start with an example question. So, determine whether the triangles are similar. Explain your reasoning. All right, so we got JL and QM. So they're kind of walking us through this first one. So JL is 12, and QM is 9. And just because I read that way doesn't mean we turn that 9 to a 6. So it'll be 12 over 9. Let's see. Which reduces down. So 3 goes into 9 3 times. 3 goes into 12 4 times. Okay. All right, let's look at LK. So that's 8. And MP, that's 6. All right, well, 2 goes into 6 3 times, and it goes into 8 4 times. All right, now we got JK and QP. JK 16. QP is 12. All right, so 4 will go into both of these. 4 goes into 12 3 times, and it goes into 16 4 times. So they're all in proportion. So, and we'll go under because it's by the side similarity theorem. JLK is congruent to, so we got JLK, it was QMP. Oops, P. Kind of helps, say JLK, so it was JLK, QMP. It kind of told me where to go. And that's terrible. Let me just QMP. All right. 2. Let's see. All right, so for example, number 2 here. So determine the triangles are similar. Explain your reasoning. Gonna help you a little bit with this. Actually, you know what? No, I'm gonna go ahead and do this one. Sorry. All right, so we've got YWX and I don't think these are sitting like this. I think they're like this. So it's YWX and TWZ. And if you look here, so TWZ, YWX. So without looking, it was there, but I wanted to kind of show you guys a couple of ways of seeing that. So it's asking if they're similar. it's saying it is here, but we need to figure out. So let's check the sides. So they say TW is 10, and YW is 20, and then WZ is 11, and WX is 22. On both of these, so 10 over 20 is a half, and 11 over 12 is a half. So here's your two sides. Sides. All right, now an angle. Now, they point this out, and I want you guys to get to the point where you don't need me or the book to point it out. But anytime you have two angles where two lines intersected and make an X, they are vertical angles. And vertical angles, the one to the left and the right are congruent, and the top and the bottom. But of course here, these are not part of our triangle, but this is important here. So YWX, so it would be TWX on the other side. Sorry, TWZ, excuse me. And it's because this angle and this angle are congruent because they're vertical angles. So there's your A. So it's by side angle side, or side angle side, that they are similar. All right. Oops, sorry for all the shaking. Blair Witch going on here. Let's go down to the bottom to example 2. One second. Sorry, excuse me. Got distracted. Okay, example 2, bottom of the page. Find QN and PO, justify your answer. So, now, you notice these are two triangles, one on top of the other. So, just like this side, so this goes with the whole thing, this goes with the whole thing. Because it takes both of these to make the bottom triangle. I want us to understand that. These are like this, and then the other one is both of them together. So just as long as we get that. So QN and PO, we got to solve for X. We got to figure out. Well, first let's go. So let's just start here. So MQ to MP. Then the other side would be MN. Oops, MN to MO. And then you have QN to OP. So let's see. These should all be in the same proportion. So 5 is MQ. And then MP is 5 plus 3, which is 8. Over here, 6. And I think there was an issue with this problem, but maybe not. We can get the... Actually, we don't do this. We're just doing the different proportions. So 6, and then this would be 9. And 3/5 is the same as point... hold on, 3/5 is 0.3. Just, my mind went blank. Goodness. Yeah, 0.6. It's a 9.6. And over here you have X over X plus, and 2 1/4 is the same as 2.25 or 2 1/4. So let's use the 5 and the 8. Let's go over here. Say 5 over 8 equals X over X plus 2.25. Cross multiply with our little butterfly. All right, so 8 times X is 8X. Oops, equals 5 times X is 5X plus 5 times 2 1/4 is 11.25. So let's subtract 5X from both sides. That gives us 3X equals 11.25, and when you divide both sides by 3, X is going to equal 3.75. All right, so they want QN and PO. All right, so QN was X. So X is 3.75. And then here, PO is X plus 2.24. So 3.75 plus 25, not, and that equals 6. Okay. Let's see, flipping over. All right, whoops. All right, let's do this quickly. All right, top of the page. Assuming triangle WRS is similar to triangle TVW, find WR and RT. All right, so let's just put this over here. This worked better earlier. WR is X plus 6. So it's right here. WR. All right, and RT is 2X plus 6. So when we find X, we'll have it here. All right, so WR goes with TV, and then TR, wait a minute, yeah. Something's not, this is not right. This is, yeah, it's TVR, not TVW. I was like, wait a minute, something's not right. Okay. Now, yeah, because it's in the middle. Notice vertical angles here. I'm not going to always point these out to you guys, but I hope that I point them out enough that you get it. See, that's an X, so each side of R is an angle. Actually, I don't think that really pertains to the problem, but I always like to point them out. So anyway, yeah, just good info to know, but not relevant at the moment. All right, let's see. We got TV, WS. I'm sorry, WS. And it's a TV, WS, TR. So let me just rewrite this over here. So TR, WR. So let's line up our stuff here. So TV is 10. Well, I can just go down below it. And WS is 8. TR is 2X plus 6. And WR is X plus 6. So we're going to cross multiply these guys. And before we do that, so looking here, so WR is proportional to TR. RS, so the other one would be VR, or RS would be RV. And then SW, that's the other guy. Remember, it's with TV. We'll just write those over here while we're there. All right, now, so 10 times X, 10X. 10 times 6, 60. 8 times 2X is 16X. Plus 8 times 6 is 48. Subtract the 10X from both sides. And we're going to double up here, okay? Before we go down, because you know this is going to cancel out. We're moving our X's over here. I'm going to go ahead and subtract 48 from both sides. So these cancel, these cancel. 16x minus 10x is 6x. And then over here, 60 minus 48 is 12. We just did the two steps. We combined them. We're going to divide both sides by 6. And 12 divided by 6 is 2. So x equals 2. We'll plug it up here. So WR is x plus 6. So 2 plus 6. 2 plus 6 is 8. And then T, 2x, so 2 times 2 is 4. 4 plus 6 is 10. Okay? All right. Excuse me. Example 3, check. And this one's a little tough. So in class, we did this. So I'm going to go ahead and show you this, even though this is technically an I do. All right, so it says Justin is playing tennis. When serving, he stands 12 feet away from the net, which the net is 3 feet tall. The ball is served at a height of 7.5 feet. Justin thinks the ball travels about 21.4 feet before it hits the ground 8 feet from the net on the opposite side. How far does the ball travel before it reaches the net? Round to the nearest tenth. So it's a little tough. So I'm going to draw this out. All right, so we got Justin here, all right? And let's see. So he stands, so here's the net. Net is 3 feet tall. He stands 12 feet away from the net. He's going to throw, let's see, and then the back wall. And the net is 8 feet in front of the back wall. All right. I'm just going to put net here. And he's talking about the ball is going to be 7.5 feet. So he's throwing the ball. And we're going to do this. So from here to the net is going to be X. And from here, from the net to the back wall is Y. He's saying that the ball is going to travel. So from here to there is going to be 21.4 feet. 7.5 feet to the back wall. He's 12 away from the net. The net's 3 feet tall, and the ground to the net, the back is 8 feet there. Okay. So we just have a triangle. What you have is like we had before. We have a triangle that looks like this, and it's going to be 12 here, 8 here. So we're saying X and Y, and Y is going to be 21.4 minus X, because it's 21.4 feet. We're going to find X, and then to find Y, we're going to subtract it from the whole amount. So let's do that. We're going to say, all right, so X to 21.4, because we have the total, is going to be 12 to 12 plus 8. 12 plus 8 is 20. And then we cross multiply. Butterfly it. All right, so X times 20 is 20X. 12 times 21.4 is 256.8. We're dividing both sides by 20. So X is going to equal 12.84 feet. And that's going to make Y, so 21.4 minus 12.84, we get 8.56. So how far does it reach? And it says to the nearest tenth, so 8.56, it's going to be 8.6 feet. So always pay close attention to what it's asking. So we're going to end up with 8.6 feet. Sorry for all the craziness there. Now, here at the bottom, are these two triangles similar? How do you know? So I'm going to leave this for you guys. I'm going to give you one last little piece of advice. I'm going to highlight that X in the middle. Draw an arrow that says vertical angles, because that tells you that these guys, so you do have an angle. You just need to know if these two sides are congruent. You're going to do one side to the other, one side to the other. You know, if you start on the right to the top, it's right, left, right over left, right over left. Just make sure you do it the same. You can kind of look here and see that one of these is not like the rest of those guys. So hopefully you got that much. Anyway, excuse me. All right, sorry for the technical difficulties. If you have any questions, send me a message on Focus or Teams. If you're new to the channel, please consider subscribing. Until next time.